Hello, children. Before starting lecture number 5 of Mathematics Class 8, chapter number 6, Squares and Square Roots, let us quickly revise few concepts of this chapter. In the previous chapter, we have learned about the square of a number. So, what do you mean by square of a number? Square of a number is the product of the number by itself. After that, we have studied how to find out whether a given natural number is a perfect square or not. So, the prime factorization is the method which we have learned to find out whether a given natural number is a perfect square or not. So, a perfect square can always be expressed as the product of pairs of equal prime factors. After that, we have learned few properties of the square numbers, like a number having 2, 3, 7 or 8 at its units place is never a square number. Next property which we have learned is a number ending in odd number of zeros is never a perfect square. Next property which we have learned is squares of even natural numbers are even. Squares of odd natural numbers are odd. Now, apart from these properties, we have also learned if a number has 1 or 9 in the units place, then its square ends in 1. If a number has 4 or 6 in the units place, then its square ends in 6. If a number has 2 or 8 in the units place, then its square ends in 4. If a number has 3 or 7 in the units place, then its square ends in 9. If a number has 5 in the units place, then its square ends in 5. If a number has 0 in the units place, then its square ends in 0. So, in this lecture number 5, we shall review more properties of the square numbers. Now, and at the end of this lecture, I will be discussing the homework questions of the previous lecture, that is lecture number 4. Coming to more properties of square numbers now. The very first property is if we could arrange the dotted pattern of the numbers in a triangular form, then these numbers are called triangular numbers. It means if I am arranging the numbers like 1, 3, 6 in the form of a pattern, if I am arranging the dotted pattern of the numbers in the triangular form, then these numbers are known as triangular numbers. And if I am adding two consecutive triangular numbers, like it can be seen in the pattern also, 1 plus 3 will give you 4, 1 and 3. Together they are making a square, so it is a square number that is equal to 2 square, that is equal to 4. Likewise, in the second pattern, we have observed that if I am arranging 3 and 6, in two triangular numbers 3 and 6 in the form of a square, then I will be getting a square number, that is 9, which is equal to 3 square. Similarly, in the third pattern, if I am arranging 6 and 10 in the form of a square, I will be getting a square number, that is 16, which is equal to 4 square. So, if I could arrange the dotted pattern of the numbers in a triangular form, then those numbers are called triangular numbers. And if I am adding two triangular numbers, two consecutive triangular numbers, then we get a square number. After that, numbers between consecutive square numbers. If I have a look at the given pattern, then I will observe the following, which I will be discussing later on. Let us review the pattern first. 1 is equal to 1 square. Obviously, 1 square is 1. 2, 3, 4, that is equal to 4 is equal to 2 square. So, between 2 square and 1 square, 2 and 3 are the non-square numbers or two natural numbers which are lying between the square of 2 and 1. Likewise, 3 square and 2 square, between 3 square and 2 square, 5, 6, 7 and 8 are the numbers which lie between 3 square and 2 square. Similarly, 4 square, between 4 square and 3 square, 10, 11, 12, 13, 14, 15. All these are the natural numbers which lie between two consecutive square numbers. Now, on observing this pattern, we can conclude that 2 square minus 1 square, that is equal to 3, and non-square numbers between 1 square and 2 square is equal to 3. is equal to 2. That is 2 into 1, which is 1 less than the difference of the squares, and the numbers are 2 and 3. On observing this pattern, we can conclude in a general manner that there are 2n non-square numbers between the squares of two consecutive numbers, that is n and n plus 1. So the condition should be there should be squares of two consecutive numbers, then 2n will be the non-square numbers which will lie between the squares of two consecutive numbers, that is n and n plus 1. For example, if I need to find out non-square numbers or natural numbers between 9 square and 10 square, then it will be 18. How? Using this formula 2 into n here is 9 and n plus 1 here is 10. So 2 into 9, that will give you 18. So 18 natural numbers lie between 9 square and 10 square. Third property is, if the number is a square number, then it has to be the sum of successive odd numbers starting from 1. For example, if I am taking 3 square, that is equal to 9, the sum of successive odd numbers from 1 will be 1 plus 3 plus 5, that will give you 1. You can take 2 square also, that is equal to 4. So 1 plus 3 will give you 4. So it can be observed as that if a natural number cannot be expressed as a sum of successive odd natural numbers starting with 1, then it is not a perfect square. So in the previous lecture, we have learned that using prime factorization, we can come to know whether the given number is a perfect square or not. And this is another way to find out whether the given number is a perfect square or not. From that number, we need to represent that number as the sum of successive odd numbers. Now, coming to Pythagorean triplet. Pythagorean triplet, if the sum of two square numbers results into a square number, then all these three numbers form a Pythagorean triplet. For example, 3 square plus 4 square, that is equal to 9 plus 16 will give you 25, which is again a square number. So, what do you mean by Pythagorean triplet? If the sum of two square numbers, 3 square and 4 square, 3 and 4 are square numbers, their sum will result into another square number, that is equal to 5 square, that is equal to 25, then all these three numbers form a Pythagorean triplet. That is, the collection of the numbers 3, 4 and 5 is known as Pythagorean triplet. So, for any natural number m greater than 1, we have 2m square plus m square minus 1 square is equal to m square plus 1 whole square. So 2m, m square minus 1 and m square plus 1 forms a Pythagorean triplet. So dear children, in this lecture we have learned the properties like adding triangular numbers. If I am adding triangular numbers, I will be getting square numbers. And what are triangular numbers? If the numbers whose dot patterns can be arranged as triangles are called triangular numbers. Like we have learned that 1, 3, 6, 10, etc. are these triangular numbers. And if I will combine these two consecutive triangular numbers, I will be getting a square number. For example, 1 plus 3 will give you 4, that is equal to 2 square. Likewise, 3 plus 6 is equal to 9, that will give you 3 square. Likewise, you can add two triangular numbers and get square numbers. Now, next we have learned how many numbers will lie between the two consecutive square numbers, and the formula is 2n. So 2n will give you non-square numbers or natural numbers which will lie between the squares of two consecutive numbers, that is n and n plus 1. We have taken one example also. I hope it is clear to you. Now, next we have studied that if I am able to represent a number as the sum of successive odd natural numbers starting with 1, then it is a perfect square. Next, after that, we have learnt about the Pythagorean triplet, which is 2m, m square minus 1 and m square plus 1 forms a Pythagorean triplet. Next property is sum of first n natural odd numbers is n square. Looking at the pattern, 1 is equal to 1 square definitely. 1 plus 3 is equal to 4, that is equal to 2 square. 1 plus 3 plus 5, that is equal to 9, that is equal to 3 square. Likewise, if I am adding 4 natural numbers, I'm getting the sum as 16, that is equal to 4 square. If I'm adding 5 natural numbers, if I'm getting the sum as 5 square, that is 25. Likewise, if I need to find out the sum of first n odd natural numbers, then its sum will be n square. I hope all the properties are clear to you. Now, coming to the homework part. Dear students, you are supposed to complete exercise 6.1, question number 7, first part and third part, question number 8, second part, question number 9, third part in your homework notebook, exercise 6.2, complete question number 1 third part, question 2 fourth part in your homework notebook, and exercise 6.3 you are supposed to complete question number 1 in book. All these questions you are supposed to do from the NCERT book only. Now, after that, coming to homework solutions of lecture number 4, that is the previous lecture. Question number 1 is, what will be the unit digit of the squares of the following numbers? Students, we have revised the properties of square numbers in the beginning of this lecture. Again, I am repeating the properties, like if a number has 1 or 9 in the unit place, then its square ends in 1. If a number has 4 or 6 in the units place, then its square ends in 6. If a number has 2 or 8 in the units place, then its square ends in 4. If a number has 3 or 7 in the units place, then its square ends in 9. If a number has 5 in the units place, then its square ends in 5. If a number has 0 in the units place, then its square ends in 0. So, according to the square numbers property, that is, if a number has either 2 or 8 as its units digit, then its square ends in 4, as 2 square is 4 and 8 square is 64. So, the digit at one's place will be 4. Coming to next question. The following numbers are obviously not perfect squares. Give reasons. In this very question, we are supposed to find out the reason why the given numbers are not perfect squares. Students, we have learnt that if a number having 2, 3, 7 or 8 at its unit place is never a square number, so we will be using this concept, and we will be writing directly that 1057 is not a perfect square since it ends with 7 at units place. 7928 is again not a perfect square since it ends with 8 at units place. Question number 1 and question number 2, you are supposed to complete these very questions, all the parts of these two questions, question number 1 and question number 2. I have taken here only two parts, so you can complete rest of the parts on the basis of this explanation. Coming to question number 3. Question number 3 says the squares of which of the following would be odd numbers. As we have discussed that if I am squaring any odd number, then the square of that odd number will be definitely odd, and if I will be squaring an even number, the square of that number will be even. Using this property, you can write down square of 777 would be odd. As per the property of square number, square of an odd number is always odd. Children, I hope all these properties are very much clear to you. Let us quickly revise what we have learned here in this lecture. We have learned about triangular numbers, that if I am adding triangular number, if I am able to represent the numbers whose dot patterns can be arranged as triangles, then those are triangular numbers like 1, 3, 6, 10 and 15. If we combine two triangular numbers, then we get a square number. If next property which we have learned here in this lecture is numbers between consecutive square numbers. If I need to find out n natural numbers between squares of two consecutive numbers, then it will be given by the formula 2n. Then after that, we have learned that if a natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. Also, we have learned about the Pythagorean triplet, which says that 2m, m square minus 1, m square plus 1 forms a Pythagorean triplet. So children, you are supposed to complete the questions from NCERT book, which we have discussed right now, on the basis of those concepts which we have discussed, and this lecture number 4 homework solutions we have also discussed. So you are supposed to complete those questions also. Question number 1, 2 and 3 of exercise 6.1, you're supposed to complete all the parts of those questions in your homework notebook. Thank you.